Hello again. Notice the different background on this micro lecture. That's because it is optional. Anytime a micro lecture is like a little different than the average, we'll change the background color. That's why the intro and outro are the red background and the actual kind of like content lectures are a dark purple background. So this one's content related, but it is optional. So again, you don't need to do it. If you're fairly comfortable with the idea of slope and how to figure out slope from a graph or what a tangent line is, then you should do this. It's good for you. And if you're considering IB physics, you really should do this. If neither of those apply to you, then feel free to skip this video. Or if you just want the extra challenge, feel free. But we're going to be focusing on how do you calculate acceleration from a distance time graph. We've talked about what acceleration looks like on distance time graph. It's curved, but we don't really know how to get acceleration from it, and that's what will be the focus of this one. Before we get started, a little reminder. Remember that on a position or distance graph, the slope means velocity. So if you want to know the velocity at a couple different points, you would look at the slope at that point. For a line where the velocity and therefore slope doesn't change, you can pick any point and figure it out. But if you look at something where the line is changing in velocity, you need to figure out the slope at different points. So remember, curved line means velocity is changing. So if I want to figure out acceleration, I need to know how much did the velocity change and how long did it take in time. So literally the time between, let's say, this point right here and this point right here, and how much did the velocity change from this point to this point. To do that, you might look at a tangent line. In other words, you'd look at the slope of a tangent line, a line drawn kind of right next to this one, and the slope of a tangent line there, and that would give you ideas about the change in velocity. And then you could also combine that with information about the graph's time. So you look at two velocities and two times, and then you can get your acceleration. I'm purposefully leaving a few of the kind of ideas a little vague, although many of you should have enough information to try this. Give it a shot in the Google form and see if you get it right. Remember, 3 bullet points worth of notes, a 1 to 2 sentence summary, and do your follow-up questions.